Okay, so sorry, just going to tighten this. So we're going to have a look at building the SDR board. And so there's a couple of things that we need. So there's 3 SMA connectors. There's a toroid, a 4-pin 0.1 inch header, and yeah, that's pretty much it. So what we'll do is we'll do the coil. See if this is in shot. So to do the coil, we're going to wind the trifilar wound inductor. So we take about 8 inches or 20 centimeters of wire, three of them. And the idea is basically to put these together and to wind them like such. Hopefully this is coming out okay. Now, so basically you have to wind this the whole way along. I normally do it in the vise, but I'll see if I can do it in the vise, sitting on the bench where you can actually see it, but mightn't be too easy. So, sorry, which way have I started winding this? This way. No. So I'll do it by hand here, and simply just wind them. So I have to take it off camera, but basically what I've done is I grabbed this side here in the tweezers, just wrap that around there, and you just simply turn, and you just keep turning like that, and you should end up with 3 wires wound around each other, just like that. So put the vise back here. So now we need to put 10 turns of this through the toroid, and every time you go through the center, that's a turn. So that's 1 turn, and so on. 2, 3, 4, and 5. Do some of the other side. So I'm just going to snip. And that's 6, 7, 8, 9, and 10. Okay, so this is going to be inserted into the board here, and just to give you that, so basically 1 wire will go from this pin to this pin, 2nd wire from this pin to this pin, and 3rd wire from this pin to this pin. So all we need to do now is just to basically cut these, tin it, and just make sure that we know which wire is which. So with the enamel wire on this, it's actually, you can just use a hot soldering iron to tin it. It'll melt the enamel off. So let's just do that. if I can do it without getting my head in the way as normal, it would be good. Put that in. So hopefully that's clear that they're all tinned. Then we'll do the other three. Yeah. You may hear some guys in the background.
An odd time there, you went down to 10 over rather than...
Not sure. It's an Irish guy, some EI call sign, I guess. Okay, so now we need to know that we're in the right order. I can't see my... I'll do the multimeter off camera. And I'll put it on the diode so that we can hear it beep, hopefully. So we just need to make sure that we have them in the right order. Kind of finicky here now, but let's just get the first wire. And so this is the first, and that's actually perfect. So these two are connected, and that's the order that we want them in. So let's see if we're really lucky. Ah, okay. Next two are in order as well. And it'd be very unusual if it's heard. I think I'm hitting two pins there at once, just to make sure I didn't mess up on the middle one. Yeah. So they're actually all in order straight away. So much for Murphy's Law. So we basically just need to put these in that order into the board. And let's just bend this guy here. Okay, so that's one side. So I'll just get one of the wires tacked in there. Okay. So let's just do the next two here. And just going to double check this. And is that telling me I haven't soldered this guy properly? I think so. Looks like a dry joint there. No, I'm not fully happy with that now. Sorry, the cables are. Okay, I think there was a little bit of what you call it, flux on the pad, and that was causing it not to connect. So I just put in these three now. The next three wires at this side. And we get them soldered in. Okay, so that's our toroid in position. So now we just need to put in our the SMA connectors, and if you have blue tack, you could possibly use that. I'm just going to use some insulating tape. And we're putting these in. The idea is just to solder the center one. Don't solder them all, because if you do, it gets really hard to align the part after. And you'd end up with something like this. So always check the alignment that it is sitting in correctly before soldering the rest of them. Okay. And the grounds do take a good lot of heat. Okay, so I got these two soldered in, and I'm just putting this one in. So again, I'm just going to solder the center one. Oh, should have let it cool. Okay. More haste, less speed. Sometimes. Okay. Take number 2. And let it cool. Okay. What's the alignment like for that? Not perfect. And now it is. Okay. Okay, so they're all soldered in, and just using some IPA here just to give it a clean. Okay, that looks good. And then the last one is this connector. So this goes on the opposite side of the board, and I won't do it this time, but when I put these in, normally I put them into the actual the RadioLab itself. Actually, you know what? I'll do it, because it is the best way of doing it. So we'll take a RadioLab here. and we'll plug the connector into it. Plug that in and screw this in position. So now we know when we solder this that everything is going to line up perfectly when we go to insert it again. Okay, that's good. So we know that this is definitely aligned correctly now. So then we need to test this. So I'm going to put it into the RadioLab and we'll give it a test. Okay, so there's a connection diagram on the web in the support area. So it just shows how to connect the I2S as opposed to connection. So the I2S, for anybody who's not familiar, is for digital audio. So we take in the audio and then we process it using Hilbert filters within the ESP32. That allows us to do SSB and CW. So we have two clocks. The way I programmed the software that in was, let me just change this here maybe a little bit. Clock 1 and clock 3. It could have been clock 1 and clock 2. It really doesn't matter. I just happened to program with clock 1 and clock 3. So clock 3 goes to oscillator 2. Clock 1 goes to oscillator 1. And all the software is fully open source, so you can change that any way you like. And need to put on some jumpers on the board as well. So there's four jumpers on the board. And what these allow you to do is if you want to create your own circuits, you can tap into these here. So this is to take the I and the Q and feed it into the analog to digital converter. And then this is taking the output from the DAC to an op amp, which allows you to adjust the balance, so you get allows you to maximize the opposite sideband suppression. Okay, so we have 4 jumpers in, and let's give it a test. I think there's a competition on at the moment. So that's, you can adjust the filters and so on. And the opposite suppression seems to be quite good, even without adjusting it. Yeah, it's really, really good. What we normally do is connect a safe signal generator and do it, and I will do that, but let's see now, there's a strong signal. So it's so anyway, I will do it. I will do it. It's too noisy for me to adjust it right now. But I will do a video on adjust it using a signal generator. And if we are really smart, what we should be able to do is actually program one of these clocks to, let's say, 7020, 7.02 megahertz, we'll say, and loosely couple that into the antenna one, so even just have two wires slightly wound around each other. And then once that's done, we should be able to go to the sideband where we want to reject, and just adjust the pot to minimize the output on it. And that's it. So if you don't have a signal generator, you should be able to do it by yourself. But I will upload a video on the procedure to do that. But that's ultimately how you build this guy. And you get and definitely the filter makes a huge difference. So thanks for watching, folks. Take care.